Okay, this video is going to go over different types of variation, meaning how quantities will vary in relation to each other. Alright, the first thing we're going to go over is direct variation. In direct variation, you have two quantities, x and y, as well as a constant of variation, we call it k. We write the general equation y equals the constant of variation times the other variable. And this is why we call it direct variation. It's because if one variable increases, then that means the other increases. If one of them decreases, that means the other one decreases as well, and vice versa. Now, for this example, it says the area of a rectangle varies directly as its length. If the area is 50 square meters when the length is 10 meters, find the area when the length is 25 meters. So we know the general equation, the area varies directly with its length. That would be k times the length, because one variable is equal to the constant of variation k times the length L. So after this, we have to find the constant of variation. After we come up with the general equation, we plug in our values to find our constant. So our area is 50, so we plug that in for A. And it says the length is 10. So if you solve for k, k would be 5. That means our general equation would be our area is equal to 5 times the length. Now if the length is 25 meters, then our area is equal to 5 times 25, which would be 125 square meters. Now the second thing we're going to learn about is inverse variation. Inverse variation, you have the same quantities, x and y, and you have your constant of variation, k. The general equation to get the general equation for one variable, you have to divide the other one by the constant of variation. What this means is that if one variable increases, the other one decreases. If x increases, y decreases. And if y increases, that would imply that the other variable would have to decrease. Alright, here's an example over inverse variation. It says in a certain manufacturing process, the cost of producing a simple item varies inversely as the square of the number of items produced. If 100 items are produced, each costs $2. Find the cost per item if 400 items are produced. So, alright, it says we're talking about the cost and the number of items. So I'm going to let C be the cost and N be the number of items. And it says the cost varies inversely as the square of the number of items produced. Since it's talking about the square of the number of items, we say C over N squared. So, if we plug everything in, it says if 100 items are produced, each costs $2. So 2 is equal to K over 100 squared. So this means that 2 is equal to K over 100 squared would be 10,000, because 100 times 100. So that means if you multiply both sides by 1,000, or not 1,000, 10,000 rather. That K would be equal to 10,000 times 2, so our constant variation would be 20,000. So our general equation would be the cost is equal to 20,000 divided by n squared. Now I want to know the cost per item when 400 items were produced. So when n equals 400, we have C is equal to 2,000, or 20,000 rather, divided by 400 squared. That's equal to C is equal to 20,000. Then 400 squared would be 160,000. That you could divide everything by 10,000. So it'd be 2 over 16, which would be 1/8, or 0.125. So, let me move everything up. That means the cost is equal to 12.5 cents per item. Alright, next thing we're going to talk about is what we call joint variation. It's where one quantity varies directly with more than one other quantity. Like in this example, it says the area of a triangle varies jointly as the length of the base and the height. A triangle with base 10 feet and height 4 feet has an area of 20 square feet. Find the area of the triangle with a base of 3 and a height of 8. So, we know the general equation, since it varies jointly, be K times the base times the height, the constant variation times the base times the height. That's what joint means, is that the area, since it varies jointly, it's actually varies directly with both of them. So now let's plug in our values to find our constant. Our area is 20, equal to our constant K times our base of 10 and our height of 4. So that tells you 20 is equal to 40K, which means our K is equal to 1/2. So our general equation, which you may have seen in previous math classes, our area is equal to, the area of a triangle is equal to 1/2 times the base times the height. Now it wants to know the area when the base is 3 feet and the height is 8 feet. Area is equal to 1/2 times 3 times 8. That would be 1/2 times 3 times 8 is 24. 1/2 of 24 is 12 square feet. Alright, the last type of problem we're going to do is what we call combined variation. Combined variation is where we have one quantity that varies directly with one thing and then inversely with something else. Like in this problem, it says the number of vibrations. It says it varies directly as the square root of the tension and inversely as the length of the string. So, N is the number of vibrations. T is the tension. And L is the length of the string. So it says it varies directly as the square root of the tension, so the number of vibrations varies directly with the square root of the tension, so K times T, and inversely as the length of the string. So there's our general equation, which if you haven't noticed, I've been abbreviating GEN, EQN for general equation. And it says if the number of vibrations per second is 50 when the tension is 225 newtons and the length is 0.60 meters, find the number of vibrations when the tension is 196 newtons and the length is 0.65. So, to find our constant K, the number of vibrations per second is 50. It's equal to K times the square root of the tension, which is 225, and the length is 0.60. So multiply both sides by 0.6 or 0.60, whatever. Alright, 50 times 0.6 is 30. Those cancel out, so you're left with K times square root of 225 is 15. So if you divide both sides by 15, that tells you your constant of variation is 2. So, your general equation would be 2 times the square root of the tension divided by the length of the strings. So when the tension is 196 newtons and the length is roughly 0.65 meters, we can plug it in. N is equal to 2 times the square root of 196 divided by 0.65. So square root of 196 is 14, so it would be 2 times 14 divided by 0.65, which would be 28 over 0.65, which would be roughly 43 vibrations per second.